Alright, we're back with section 8.2, but now we're working on number 44. We're looking at school vouchers. A national opinion poll found that 44% of all American adults agree that parents should be given vouchers that are good for education at any public or private school of their choice. The result was based on a small sample. How large an SRS is required to obtain a margin of error of 0.03, that is plus or minus 3% in a 99% confidence interval? Answer the question using the previous poll's result as the guessed value for p hat. And then in part B, answer the question in part A again, but this time use a conservative guess p hat equal to 0.5. By how much do the two sample sizes differ? So in general, when we're asked to find a question about the margin of error, that would be assuming that we're working before any samples were taken, trying to decide on what sample size is necessary, which is why we use a conservative value of 0.5. In this case, they're telling us that a sample was already taken, which is why in part A we're going to start with that sample proportion, and then in part B we're going to see how that would compare to if we had done the conservative value before taking a sample size. Because we're dealing with a 99% confidence interval, we should first take a look at what our z-critical value would be. So I'm going to go to my resource packet, and in the resource packet, on the very bottom of table B, if I'm looking at 99% as my confidence level, then I'm going to deal with a z-critical value of 2.576. So when I do my critical value, when I do my confidence interval, the critical value I'm going to use is 2.576. So coming back here, the margin of error comes from that z-critical value plus or minus, the z-critical value times the standard deviation. So it's normally p hat plus or minus that value, but since we're only looking at the margin of error, we're just going to focus on this value here. We just saw that our z-critical value is 2.576, and our standard deviation here, since we're dealing with a proportion, would be the square root of our p hat, which was 44%, so 0.44, times 1 minus p hat, which would be 0.56, over our sample size, which we don't know. We're trying to find that. We're checking to see when this is less than or equal to 0.03. To solve that, I would multiply both sides times 2.576. And if you go to your calculator for that, you're going to get the square root of 0.44 times 0.56 over n would be less than or equal to 0.0116. Then I would square both sides, and that gives me 0.44 times 0.56 needs to be less than or equal to. This takes me into a scientific notation, and I get 1.356 e to the negative 4. Sorry, that was over n. Now I can multiply both sides times n, and I have 0.44 times 0.56 is less than or equal to that value times n. And then I would divide both sides by that value. So I'm just working through algebra here. And by putting that in, I find that my n needs to be greater than or equal to 1816.73. So I would say that we require a sample of 1817, and we were dealing with adults here. And that would be my answer. So going on to part B, we're going to do the same thing, but this time we're using the conservative value of p hat equal to 0.5. So I would set up my equation similarly, except for on top I'm using a p hat and a 1 minus p hat of 0.5. And then if you go through the same exact algebra, you would get n needs to be greater than or equal to 1844 adults. So that means the conservative approach requires 27 more adults than what we got from having our sample size.